Internet, how are we going? It's super quiet today. Am I the only one here? Am I the only one here? Nope. All right. One is better than none. Oh, two. All right. Ah, the MCAT. That was good memories. I'm sure slow mode is actually switched off, and I'm assuming the sound is all good to go because you guys can hear me. Let me just do my last check. What, the MCAT? Raymond, I would definitely say you would need to do TEG if you're going to do level 2 calculus. It is almost a must. When did we last do this? This was 11th of September. Let's go TEG. All right, tables, equations, and graphs, people. That is pretty much what we're doing today. Yep, that's right, Bunty Place. Hey, look, so I know that like this is pretty much our starting point for tables, equations, and graphs. So today we're going to be looking at just straight lines, nothing else. We're not complicating things here. We want to actually get the basics of straight lines first. So if you are comfortable with straight lines, then I guess this is your night off. But yeah, it's pretty much linear. We're going to be covering linear graphs here. That's pretty much it. So here's what we're going to be doing today. So something like we're going to be given 2 points, and by the end of the end of today's session, you want to be able to say, yep, if you give me 2 points, I can actually find equation of a straight line. So pretty much this is what we're doing today. So equation of a straight line, which is also known as linear equation. We are going to be doing y equals to mx plus c. And of course we can also do the other one, which is equation of a straight line, which is this one as well. So you've got a couple of so those 3 things we're going to pretty much cover today. So in saying that, we are going to get started. I need to just give me a second. I just need to load up Desmos on the side here so that we've got a graphing calculator ready to go. No, Martin, they're the same. Hey Archie, how you going? They're pretty much the same equations. I mean, you can use either equation, and I'm going to show you guys both. All right, so here we go. So what are we going to do? We need a couple of points to start off with. Minus 2, 4, and we're going to do minus 2, 4, and 6 and 8. Let's do that. So what we're going to do is, our first question that we're going to do is, I will actually take a screenshot of it and just dump it in here so you guys can actually have a look at it. And then what we'll try and do is we'll actually probably try and do the question as well. So let me just see if I can dump it here, and then we should be able to go through level 1 TEG. Come on, sync up, my friend. So guys, don't worry today. We're, like I said, we're just going to be doing basic linear equation. So I'm gonna show you guys how to do it in the graphics calculator. I'm gonna show you guys how to do it manually as well, using both of those equations there. So here we go. Hopefully that's gonna work. Control is the one that I want to do. All right, there we go. The image is going to be popping up very shortly. So here, what we've got here is we've actually got 2 points here, and one of the things the question could be like is find the equation of this line. Let's get rid of a few things here. So we want to be able to find the equation of the 2 lines. Now, so as I said to you guys before, I'm going to show you guys how to do it in 3 different ways here. So the first is graphics calculator. The second is, you know, you've got to find the gradient, and then use those 2 different formulas, whichever formula actually works for you. So the first step I'm going to do is I am going to show you guys how to use the calculator. Now you are allowed to use the graphics calculator for this. So it's not like, oh, you have to show all the working and things like that. So if you are using the graphics calculator, I do have a playlist on the graphics calculator section where you could go how to find the equation of a straight line given 2 points. It is, where is it? That's a good question. Where is it? Right, so what we're going to do is we're going to go into our main page there, and if you kind of go down, there's a graphics calculator playlist, and click on that. Oof, that is some old stuff. I need to change up a few things, but there we go. That's the video that you are looking at, which is finding an equation of a straight line given 2 points. All right, that's the video that you want to be watching if you want to practice some more of this. All right. So, in saying that, I'm just going to go through it real quickly here, so you guys can always watch it later. So what we're going to do is we're going to click on menu, go into the surprisingly the stat mode. And we're going to put in our 2 points here. So we've actually got -2. So we write our x values on the list 1 and y values on list 2. So we've got -2 and +6. Then we've got 4 and we've actually got 8. Okay. So now that we've actually put those 2 points in, what we're going to do is we're going to click on graph. We're going to click on graph 1. And there's my 2 points. Now we're going to click on calc, and we are going to use this particular thing here, which is going to give us the equation of a straight line. So when you click on this, it is going to give you this linear equation, right? Now notice how it says A is 0.5, B is 5, R is 1, R squared is 1. Like, you don't really need to worry about the R and R squared. Now these calculators, you know, normally, you know, when you think of straight line, you think of y equals mx plus c. They don't have mx plus c in this calculator. Instead, they have ax plus b. So all you have to do is just replace the a with 0.5 and the b with +5. So if you want to write the equation of this straight line, you are going to get y is equal to 0.5x plus 5. Now, generally speaking, guys, these types of straight line questions will be an achieved questions. So if they have like a straight line equation and they ask you to find the equation of the straight line, then it's just going to be an achieved question. All right, and remember, like I said to you, this is going to be method 1. So method 1 is actually using the graphics calculator, and you are allowed to use it. So there is nothing wrong with you using the graphics calculator. However, like Raymond was asking before, if I'm actually going into level 2 calculus or level 3 calculus, I would strongly recommend that you guys actually learn how to use the formula. No, Jaden, you don't actually need to say that you did anything on the calculator. You can just put the answer straight away. Okay, so how do we actually work out this in a manual way? Now, the first thing you kind of have to understand is when we take this equation, y equals to mx plus c. Now what I'm going to do is I'm going to draw like a rough sketch. I should have actually done it properly, but I do apologize, but I'm going to try. Okay, that's roughly my straight line right there. So a couple of things to understand. First thing is your C value. Now, interestingly enough, if you think about the C value is always when x equals to 0. All right, so when we have x is equal to 0, the y value is equal to C. Now, in other words, this is also known as the y-intercept. So the y-intercept is, let me just put this, I'm going to highlight all of this in green, is this part right there, the green part that I've actually highlighted. This is known as the y-intercept because you're literally looking at when is this line cutting the y-axis. And here in this particular case, you can kind of see that this is actually going to be 5. And if you look at the y-intercept, when according to the graphics calculator, we found out to be 5 as well. So sometimes you can actually pick the y-intercept from the graph straight away. Other times you actually have to kind of, you got to prove it. So that's pretty much the y-intercept. Now the next thing is the m itself. The m is also known as the gradient. It is also known as slope. Sometimes it's like some people say it as rise over run. All of these things here, they're all just different words for the gradient. Okay, so that means we need to actually figure out what the rise and run is. Now I should have chosen a better color because I should have chosen like black so that you guys could actually see the numbers better. But if you look at it, if we look at this part right here, and then I'm going to have this part in pink. So this is rise, this is run. So if I was to work out the gradient, so when I actually have the gradient or the m, so sometimes people actually write this formula, m equals to change in y over change in x. You could also do it like this. You could actually write this as y2 minus y1 divided by x2 minus x1. All right. So either way that you guys actually think about this, it's kind of going to work out. Now you might be thinking, whoa, where did this y2, y1, x2, x1 come from? Basically, all it's saying is that x1, y1 is your first point. So if I say this is x1, y1, and I'm going to say this is x2, y2. So it's basically saying when it says x1, y1, it's actually telling you for the first point what's the x value, and for the y1 is basically for the first point what's the y value. So if you look at it, it just kind of all these numbers, these letters just match up. So we can actually say y2 was 8, y1 is 4, x2 was 6, and x1 is actually -2. So it's going to be -2. So when we do this, we're going to get m is equal to 4 divided by 6 plus 2, which is 8, and 4 divided by 8 is 0.5. Now what you guys will notice in the original answer that we had from the graphics calculator, we had 0.5 as the gradient. We also had the +5 as our y-intercept. So basically at this point you guys have got two options. You could actually go and use the original equation, which is the y equals mx plus c, or you could use the second equation. It doesn't, and that's the thing, it doesn't really matter. But let's say I want to use y equals mx plus c. So if I use y equals mx plus c, I know what the gradient is, which is 0.5, and you could actually choose any point. You could choose the 6, 8, or you could choose -2, 4. It doesn't really matter. I am going to choose 6, 8 in this case, so that's my x and y value. So I'm going to substitute y as 8, m is 0.5, x is 6, and then c, I don't know what it is. So then I'm going to get 8 is equal to 0.5 times 6 is 3 plus c. So rearranging this, I'm going to get 8 minus 3 is equal to c, so I'm going to get c is equal to 5. Therefore, I can write this as y is equal to 0.5x plus 5. Now, I know this is like a long-winded way of doing it, but when it comes to like certain questions where you have to shift the graph, or like what would happen to this graph if you change this point, knowing this method just helps you a lot more than just doing it straight in the calculator. Now, I know somebody earlier asked me this question. It's like, hey, does it matter which of those equations that you use? Now, let's say you want to use this equation, y minus y1 equals m times x minus x1. Let's say we want to use that. And we could use any points, guys. You could use -2, 4, or you could do 6, 8. It doesn't really matter. For this case, I'm going to use -2, 4, so I can show you guys what would actually happen. So my y1 is 4, my m is 0.5, and my x1 is -2. So I've got y take away 4 equals 0.5x. Now, minus 2, it just becomes plus 2. Then I've got to expand the brackets. And when I expand the bracket, what I'm going to get is 0.5x plus 1. And of course, rearranging this, I'm going to get 0.5x plus 1. And that minus 4 is going to change into a positive 4. And so my equation is 0.5x plus 5. So basically, I've shown you guys, this is method 2, and then this is method 3. But before you get to method 2 or 3, you actually need to find the gradient first, and then you could do method 2, or you could do method 3. I don't like that. Let's try this. So the idea being is that like what you guys want to be comfortable with is just working with those gradients and that equation. Particularly if you are thinking about doing calculus or level 2 maths, this stuff, like especially at level 2 and level 3, it's almost like you need this as bread and butter without actually using a calculator. APAG, no, there is no such thing as extra marks for this. Like I said to you guys before, it's like if you use the graphics calculator or this, you're still going to get the same mark. But if you're planning to do calculus at level 3, or if you're planning to do maths at level 2, I would strongly recommend that you guys practice 2 and 3, and almost use the method 1 as a practice, right? Like it's kind of like to check that you're on the right track. So what I'm going to do is I will actually put another question up for you guys, and I'd like you guys to give it a go. All right, so let's give this a go, and then I'll try and answer some questions on the chat. So how about you guys try? I mean, like, look, this is all we're doing today, guys. Like, we're just starting linear algebra. Sorry, not linear algebra, linear equations. So we're just starting this, and we want to make sure we get this sussed out. Once you're solid with this, the next session we can actually do some quadratic and exponential. So I'm going to give you guys a couple of points here first. Let's go with so try this one here, 2, 5 and 3, 8. Try that one. And then, so that's going to be A, and then I'll give you guys another question, which is going to be set B. All right, so I've got those 2 questions for you guys, and what I'll do is I'll give you guys about 3 to 4 minutes just to have a good go with this. And remember, it's fine if you make mistakes. I mean, that's how we learn, guys. So it doesn't really matter. So remember, step 1, you want to actually work out the gradient. So I might do, it's like, what color should I use? Step 1, step 1, step 1. I might just put here, 1, find M, 2, choose point, and then 3, find equation. So I want equations for all of these 2 questions, and I'll actually leave the working up there for you guys so that you guys can actually have a look at it. All right, Jack, how's your night? So far, it's been pretty cool, but I'm tired, and I'm coming to the end of term. So let's see how this goes. I mean, I'm really trying not to have this big bar of Toblerone that Mum got me from the airport. So let's see how that goes. How can we get merit with this paper? Anna, what you want to be doing is you want to be able to be confident in using the graphics calculator, number 1. Number 2 is actually figuring out, like there's 3 types of questions they ask, right? I mean, there's linear, there's quadratic, and there's exponential. And you want to be pretty much confident with at least 2 of them if you're trying to aim for merit, because anything, even if you feel like you're not confident in one of them, then actually, what am I saying? No, you need to be confident in all 3, because you want to get at least 1 merit question correct with each of those separate questions to get it right. So you do need to kind of learn linear, quadratic, and exponential. Jonathan, you forgot everything. I think we are restarting, so it's all good. Manav, I honestly have no idea how many that you need to get correct in the 2023 MCAT, because I don't have access to the answer schedule, or I haven't seen the questions, so it's hard for me to answer that one. Yeah, it changes, Manav. It really depends on the paper itself. Am I going to make a live for level 3 calc before the exams? I thought, didn't I do one last night, Isabel? Or was it on, I'm sure I did one. Can't remember when, but I did one this week sometime. Did my MCAT recently think about excellence? Oh, well done, Vansh. Good job. Well, I think, Anna, that's we never leave things to the last minute. That's always a bit tricky. Hey, Sangwo, welcome back. You only need 8 marks. Ainsley, I'm not sure. Is that 8 to pass the paper or per question? I'm not sure. Isabel, you can watch it. It's on. It's saved. It's available on repeat. So just go and check it out. Darian, I've actually put a playlist available on my channel. So if you go have a look, there is right at the bottom. There's a calculator tips playlist. So have a look through it, and I think you'll be all right. Oh, it's good to hear, Luke. That's always good to hear. Yeah, Jack, I mean, like, look, from what I heard, I haven't actually seen any kind of things for the MCAT, so we've got to kind of see what's happening. Do I teach a real class, or you only Infinity Plus One? Manav, I do teach it real class. I mean, I think you would have seen in that new sub video, like, it was actually my class, but it's my, I guess, you know, it's pretty hard to say, but it is actually my class. And yes, I do have a year 8 and 9 maths class. No worries, Isabel. Good luck with that. No worries, Zoe. No way. Yeah, Luke. I think that's why I was a bit nostalgic about doing that last week's exam when everything happened. I was like, this could possibly be the last time I streamed the MCAT, and you know, that video came out from new sub, so it was a bit. Yeah, it's all right. Okay, so I'm gonna go through set 1, question A, guys. So have a look through and see if you are pretty much on the right track. So the first thing I'm going to do is I'm going to call this x1 and y1, and I'm going to call this x2 and y2. So once I do that, my gradient is change in y divided by change in x, or you can actually just try and remember this formula. So basically I've got 8 minus 5 divided by 3 minus 2, and so my gradient is going to be 3 divided by 1, which is equal to 3. Alright, so that is my gradient. My gradient is m is equal to 3. And at this point I'm going to try and show you guys how to do y equals mx plus c. So I'm going to use y equals mx plus c. I'm going to choose a point, and the point I'm going to choose is 2, 5. And notice how this is x and y. So I'm going to have 5 is equal to m, which happens to be, m was 3, right? So that's m right there. So m is equal to 3, and I'm going to highlight that in blue there, times 2 plus c. Now if you're forgetting where that 2 is, that's the x. And of course I've got the y, which happens to be 5, and I'm going to put that there. So basically what I've got here is 5 is equal to 6 plus c. Rearranging this, I'm going to get 5 minus 6, and that's going to give me c is equal to -1. So the equation is going to be y is equal to 3x minus 1. Now what I'm going to do, as always guys, I'm going to put up some line numbers. Let me know if you have any questions with this before we actually move on. Luke, I'm assuming you're talking about line 6, is that correct? I will Jaden, I will go through B, don't worry about it. Yeah, so Luke, what I did there was with line 6, I actually chose this point here. So I chose that as the point. Now let's say, for example, you pick 3, 8. So if you do pick 3, 8, then what's going to happen is, I'll show you guys the same thing, but what happens if you pick 3, 8? So if I pick 3, 8, I'm still going to have this as x and y. So my x value is equal to 3, and my y value is equal to 8. So then I've got 8 equals 3 times 3 plus c. Now the first 3 here is the gradient. My next 3 is the x value, and the 8 is the y value. Now if I was to do this, I'm going to get 8 is equal to 9 plus c. Then I'm going to get 8 minus 9 equals to c, and then c is equal to -1. So you're still going to end up with the same answer, but what you want to be sure about is that you want to actually use the correct x and y value, because if you choose the wrong x and y value, like you can't choose one x value from the first point and the y value from the second point. Yes, that's correct, Luke. I'm trying to figure out where the line starts so that I can kind of see like where the line actually cuts the axis. Now that y equals mx plus c, that's what we call like a straightforward equation of a line. Jonathan, feel free to throw like which part you kind of lost at, and we can kind of work through it. But in the meantime, Jaden, I think you wanted question B. So let's kind of do question B here. Line 1, Jonathan, that's basically just a formula to calculate the gradient or the slope. Alright, so you know how you get like a straight line and it has like a slope? That's pretty much that formula on line 1. That's what that M actually stands for. It's actually saying change in y divided by change in x. Another word is rise over run. You might have heard of that as well. So that's all it is. That's all I'm doing. So I've got 2 points and I'm trying to figure out what the gradient is. So have a look at that question number, the B part there, Jonathan. So it might actually make it a bit easier. All right. So here, part B, we've actually got 2 points again. So I'm going to go x1, hang on, let's go x1, y1, x2, y2. So Jonathan, at this point, you got to work out what the slope is, what the gradient is, and the formula for the gradient is y2 minus y1, x2 minus x1. Now, if you say, oh, I can't remember, was it y2 or y1 that goes first? Honestly, guys, it doesn't matter. What matters is that your second point, like either point. I mean, you could even do y1 minus y2 divided by x2. So I'm saying you could also do it like this if you want. It's still gonna be the same. As long as those numbers are matching up on the correct side, you are pretty much good to go. All right, so those numbers can't be switched around for the gradient formula. So once we do that, I'm going to get rid of this. I don't need all of this. So I'm going to work out what my gradient is for question B, which is going to be -6 take away 3 divided by 4 take away -8. Hey Jamie, welcome. Oh, that's good to hear. Well, look, I mean, we are at TEG part 1 at the moment. We're going to be doing linear first, and then after that we'll actually go through exponential, quadratics and so on. Be patient, my friend, be patient. So here we've got -6 minus 3, which equals to -9, and then 4 take away -8 is going to be 12. So my gradient here is going to be -3/4. Now, unfortunately, we can't really do anything about this. That's just the gradient. Now, if you want to work with decimals, you can. You can actually write this as -0.75. That's also works. So that is pretty much our gradient. That is our slope right now. So it's basically saying that the line is kind of going down, right? So it's going down at -0.75. Now, we need to work out the equation. So what I'm going to do is, in this case, because I'm like, oh, I don't want to do the C thing and then work it all out again, whatever. Actually, no. I will actually stick to the y equals mx plus c because it is quite kind of simple to remember. So this is the equation of a straight line, y equals mx plus c. And the point I'm going to use is -8, 3. So this is my x value and this is my y value. So my x value is going to be -8 and my y value is going to be +3, and my gradient, which I calculated separately, is going to be -0.75. So when I put this in, I'm going to get y is equal to 3 -0.75 times x, which is -8, plus c. Yep, right. I'll actually show you how to do that in the graphics calculator as well. So then you're going to get 3 is equal to -0.75 times -8 is just 6 plus c, and we're going to get 3 take away 6 equals to c. So c is going to be -3. So that means your equation is going to be y is equal to -0.75x minus 3. Alright, so right, you wanted to actually see what it looks like in the graphics calculator. So what I'm going to do is go into menu, go into the stat mode. Obviously I've done a couple of extra questions, so I'm just going to delete all of these values, and then I'm going to type in my 2 x values. So I've got -8 and 3, then I've got +4 and -6. So those are my 2 coordinates that I've actually put in there. Next, I'm going to click on graph 1, calc, and I want to make sure I click on that x, which is that single equation of a straight line there. So I'm going to click on x, and there is, remember as I said to you guys at the start of this tutorial, like the calculator doesn't have y equals mx plus c, they have ax plus b. But if you look at the a value, which is -0.75, now that's what we've got as our gradient, and b is the y-intercept, which in this case it's actually minus 3. So yes, you can actually use the graphics calculator. I mean, like I keep saying this, but practice this method, because especially sometimes when you get like merit and excellence questions where you have to readjust the lines, using this method, it'll be so much more easier to do those merit and excellence questions if you can learn this gradient method and y equals mx plus b, learning to substitute it. Now, I would even say, like, you know, when it comes to the exam, what I would say is, like, for the exam, use the calculator, get the right answer and be done with it. But still practice this method all the time, so that as you come closer to the exam, like sometimes they'll say like, oh, what happens if -6 is now replaced by p, for example, and then you have to write like an equation which will be like an excellence question. But if you understand the principles behind here, then that excellence will become super easy. Sandbox, no, you can actually do it with 3 points for exponential. You can, but you need 2 for linear, 3 for quadratic. Unless it's like they give you a point and the vertex, then you only need 2 points for a quadratic as well. Luke, I completely hear you on your challenge, and this is something that you have to actually decide how you want to do this, right? Like, one thing that I would say is, you know, if you are not gonna carry on with maths after this year, then I would actually see whether, you know, is it something that where you can actually borrow from someone, or even buy secondhand. You know, you don't need a brand new calculator, and I think you almost need a system in your school where, like, I'll be honest, most year 13s that leave school, you know, it would actually benefit your guys' schools if you actually talk to some of the year 13s to say, hey, can you guys like leave or like resell your calculators back to the department at a half price, and so that somebody else could actually use it. So yeah, I mean, it kind of is a lot of money to spend. I completely agree with you on that one. Okay, I don't know what. All right, so in saying that, I'm just going to put one more question up for this, or are you guys happy with this? Let me know. If you want another question that you want to practice, we can do it. Otherwise, I've got something else to kind of tinker with. Let me know. Yep, we can do one more question, and I'll leave the working out for you guys so that you can kind of and again, guys, I'm gonna say this to you, like, you know, folks, this is things you just have to practice. All right, you just have to practice to get the hang of these types of questions. No, I don't think parabola is, to be honest, that hard. Like, I just think it can be like kind of annoying, but I don't think it's like hard or anything. Okay, give me 1 second. I just want to try and I used to be able to do all of this stuff, but f of x1. All right, so let's try this. No, I'm going to change the question up. Give me a second. Okay, so I'm going to give you guys 2 more points to work out of. The first point is going to be 2 and -9. And the second point is going to be -3 and +1. Yep. Let's try this one here. So again, find the gradient first. Once you find the gradient, then substitute into y equals mx plus c, and then you should be able to come up with the answer. I'm going to give you guys about a couple of minutes to try and do this. Now guys, look, if you take time with this, don't stress about it, because it's just something you just have to practice, and as you practice more and more of these questions, things will be like, oh yeah, it's starting to make sense. All right, and those initial times that you do this question, like today, if you can just get to that final answer, even with mistakes, it doesn't matter, right? Because like it's like a pattern that you got to just keep doing again and again until you get it right. So try and work through this, and then I'll go through the answer at 8:42. Sam's, we're just kind of doing very basic linear equations, so just doing y equals mx plus c. TEG is just, I find TEG quite more annoying than hard. I wouldn't call it hard, I'd just call it annoying, because I think half the time I'm trying to sit there trying to kind of understand what the question is actually asking. I find it frustrating, some of the questions, but that's me, you know, because like, I'm not gonna lie, my English is not the strongest, and sometimes I struggle to kind of like, you know, you read a question and I think I know what they're asking for, but I don't. No, Jonathan, all of these are just achieved. We're just kind of doing some of the groundwork for you to get some easy, to kind of be comfortable with merit and excellence. Luke, for achieved, I would say TEG is the easiest, like, because all you need to do is like, you know, have a graphics calculator and you're ready to go. But I think for excellence and merit, excellence definitely, I'd say TEG. Some of the questions recently have been quite like tricky. Like, I find them tricky. Oh, Jonathan, I think yeah, if you're trying to do that, then I think see if you can borrow a calculator and just kind of work, at least get used to the calculator. Don't be like that person that's like 2 days before the exam buying a calculator and then going, oh, I need to learn how to do this, and then they don't know how to use it. So if you are going to invest in it, just make sure that you kind of you know, work on that calculator much earlier. Now I'm talking about reading, Raid, like reading a question and trying to understand what they say. Oh, Anna, chance and data. No streams for that, man. Like, it's just wow. How did you find that, Anna? Did she actually survive, or? Yeah, look, you're gonna get 3 hours for this exam. I mean, if you do one exam paper, you're gonna get 3 hours for it. Chance and data, yeah, it is. It's easy. Don't get me wrong. It's easy. I have a, like, I'm not gonna lie. Like, I should show you some of my old stats comments. I'll actually find this little comment that actually we'll do this question first, and then I'll try and find that comment from one of my ex-students, which was really, really cool. Yeah. All right. So we're going to find our gradient first. So we're going to put down x1, y1, x2, y2. So our gradient is equal to y2 minus y1 divided by x2 minus x1. So gradient y2 is going to be 1, take away negative 9, divided by negative 3, take away negative 2. So the gradient is going to be 10 divided by negative 5. So the gradient is minus 2. Once we get gradient is minus 2, we're going to put in y equals mx plus c. The point I'm going to use is 2 minus 9. So that's my x and y value. So my gradient is negative 2. My x value happens to be 2. And my y value happens to be minus 9. So I've got minus 9 is equal to negative 2 times 2 plus c. I've got negative 9 equals negative 4 plus c. And then c is equal to minus 9 plus 4, which is going to give me minus 5 as c. So my equation is y equals minus 2x minus 5. Luke, theoretically, I should be able to speedrun that in 20 minutes. If I take more than 20 minutes, then the paper is theoretically too long. I have no idea, Raid. Like, I don't get any kind of notifications or anything like that. Although I have to say, you know, in some weird way, it is kind of exciting, but it's also nervous. No, I appreciate it, Raid. Thank you so much. There you go, Ted. That's a nice job there. I don't know where I saw it. I keep thinking I need to actually take this, take a screenshot of this, but I keep forgetting. Because, yeah, the comments are just like too much at the moment to keep up. All right, so, wow. That's crazy, Anna. But I have to say, I've been getting told off by my wife, because she's like, no, you're like being ridiculous. Like, you need to start doing more work around the house and so on. So it's kind of fun in that sense. All right. So are we doing another? Can we choose random numbers to put in the brackets? Jaden, no. We're not choosing random numbers. We're actually choosing one of the points. So either we're picking 2, -9, or we're picking -3 and 1. So you can't just kind of go, oh yeah, I can choose whatever I want. Hopefully that kind of makes sense, Jaden. Well, theoretically you can, Jaden. You can actually choose if you want to practice that. You could do that. Good Lord. Alright, I'll actually show you guys this. Anna, you keep asking me this question about stats, but I know people always ask about stats, but here's the funny thing. Like, I'll actually show you guys this. This was actually in one of my comments there. Fond memories of your stats class back in MH. It's funny, eh? Should I I keep thinking every time, it's like, oh, I need to come back, to the other side. But like, oh look, there's another one I found. Check, same one. Excellence in probability. That's hilarious. Excellence in probability. That was actually level 3, by the way. Is there any more stats comments there? I thought there was one more stats comment somewhere. I need to find it. Monroe High School. Right, that's a great question there, Luke. Like, you know, you're asking how, like, comparing the equations. Now, when it comes to comparing equations, like, you can look at each comparison is basically, like, for linear, you compare the gradient. For quadratic, I'll actually talk to you guys in like the next stream with quadratics. Exponential, not so much, but quadratics, you can definitely do some comparisons for each graph. But with straight lines, it's basically just like what's happening with the slope. So, you know, they might ask you like, what would happen if you increase the slope or decrease the slope, and what does that actually mean? So, yeah, so it's like, I mean, Luke, the comparing one, it's they do a lot of it with. Now they might ask you like, what would happen if you change this number? How would it affect the gradient like that? So I need to actually go and have a look at it, but I need to actually see if I can find it. I honestly I can't remember. I need to find the question to try and figure it out, because I know what you're asking about, but I need to actually look through the question to try and kind of answer that. But look, guys, I know it's kind of getting close to 8:50, but like, did you want to do another one of these questions like this, or are we happy with this type of questions? What are we thinking? I'd like to know. Yeah, no, look, I mean, I'm happy to kind of call it here. I think it's just, this is pretty much like to get you guys set up. Quadratic we'll do next time, so we'll actually do a geometric reasoning next, and then after geometric reasoning we'll actually do a quadratic, and then we'll do geometric, quadratic, and we'll exponential, and so on. So we'll kind of alternate between TEG and geometric reasoning. Now we'll definitely do parabola. I think parabola word questions and like those weird situation questions, we'll definitely do more of those types of questions. Yeah, I tend to use a bit of this, but like, let's see. Oh, good luck for it, VDuck, for tomorrow. Yeah, I can't find it. I can't actually find where this... I know it's here somewhere. I need to find it, and I'm gonna kind of be annoyed that I can't find it. Archie, no, we'll probably be doing weekly tables or maybe geometric, one of those two. We'll do one of those two, because like I'll have to basically do like kind of mix it up a bit, right? Because I know some people would be like, this is why I don't do chance and data, because it's just a lot on. Now we'll be back on Sunday, guys. Like, so I know that we're heading down to Tauranga on Thursday. So I need to kind of sleep on the Wednesday night, and then Thursday night I'll be pretty shattered by the time I come back. But next week Sunday we're going to be pretty much full on. From Sunday onwards we will, at some point I need to do the geometric reasoning paper, so I might actually do it as a live stream, so I can just kind of do it all in one shot and just record it. Flowers, I know what you're talking about. I think you're talking about 3 variables. Is that correct? Or rather than 3 numbers? I'm not understanding it. Those questions, hang on, where did it go? Yeah, no, definitely doing it over the holidays, Archie, because I just want to keep the momentum going for us. I don't want to really, because normally what happens is that if I don't do it during the holidays, I get a bit lazy and then I kind of forget it. So I would rather just keep kind of chipping away at it through the holidays. Yeah, those ones, do you have any videos on factorizing? Yes, I do have videos for that, Flowers. I think it's like, if you go down the skills section in MCAT, you're going to find it. So that would be somewhere here. Let me just show you. Where is it? Live stream, live stream, live stream. I can't even find it. Okay. So if you go into the view full playlist, I think, there we go. Factorize this. This is the one I think you're looking for. Number 15 here. Oh, that sucks. I didn't know that the timestamp was blocking all those things. That's stupid. Ugh, gotta redo those things again by the looks of it. Yeah. So that's where you're gonna find that particular video of, I think it was flowers, was it? Right now. Oh man, Luke, you're tempting me, because I've been kind of, I did do that before. So Shania, it's mixed, Shania, because it's like, I think with level 3s they tend to kind of come in when they're ready to learn, and so I'm like, you know, when they're ready they can come and do it. A lot of the level 3s actually watch the replays, unless they're doing like excellence questions, then they come in for the excellence tutorial. Otherwise they kind of just they're quite happy. They'll come when they can. I'm actually going to use that as a dad joke in my class. That is hilarious. I need to figure out how to do this. That's alright. I just... Exponential videos, I do have it. I think if you look up like how to find exponential equation, or even the live streams, guys, like if you go back to my old live streams in level 1, you will find all of the my old my old resources. You'll find it, and exponential equations is part of those live streams. This is gonna be fun. Don't do it, Sebastian. No, I have to do it. Alright guys, if there's nothing else, I might just take off, unless there's any last minute questions. Otherwise, I will actually catch you guys later. No, we're not, Jaden. No, that's it. It's enough questions for today. But we'll be back with what do you call it? What's that thing? Quadratics. Early during week 1 of the holidays, we'll come back and we'll start doing some quadratic questions there. And Luke, as much as it's tempting to do Stumble Guys right now, I think I might just call it, man. I need at least a couple of days of good rest for that long drive in Tauranga, because on Thursday I'm taking my class to Tauranga, and then from Tauranga we're going to Hamilton, and then coming back to Auckland. I was crazy enough to think, maybe I should just come outside Tauranga. I think some of you guys are from Tauranga here, and I was like, maybe I should just come outside one of the schools and just take a photo and just go, boom, was here, been there, done that, and then run away. Same with Hamilton. I was thinking about doing something silly. Should I? It'd be silly not to do it though. Flowers, no. I actually teach. I teach intermediate, so year 8 and 9. Raid. What, you should? Damn. TBC, is that Tauranga Boys College? 27th, is that September? That's next week. I am in Auckland. I'm not going anywhere. It's just a one-off trip. But it was funny because like someone actually mentioned like doing a meet and greet in Wellington at the end of the year. I was like, what do we do? Like, what do you just go to I don't know, like a library or something and just sit there with a maths book? Who knows? Do a live. Yeah, that would be quite fun, isn't it, to do something like that? All right, guys. Anyway, look, I'm gonna take off. I think what this is the last time I'm meeting this week, so have a good weekend and have a good end of term, and start off. You know, enjoy the break, and then we'll kick off things in Sunday of week one holidays, and then we will start powering through this. No, I'm not going there, Luke. That's a very dangerous territory. But I might actually post some photos of our travels on Thursday on Insta, just to kind of keep things interesting. All right, guys, take care. Have a good night, and see you later.